All right, so the next type of problem, so there are only two types of problems in this section. The next type of problem is verifying trig identities. So what is an identity? It's just an equation that's true for all values of x. So basically something that's always true on the left and the right side. And so here are some guidelines to follow. So like I mentioned, all of these problems can be solved different ways and using different techniques. But if you would like some guidelines, here they are. So this is crucial. Work with only one side of the equation. Don't try to change both sides to make it work. Just start with the more complicated side and simplify it to what the other side looks like. Then you want to look for opportunities to apply the fundamental identities. So if the expression is a product or a quotient, try using the reciprocal or quotient identities. So we used that a lot before. If you see square terms, this is important. If you see squared terms, maybe see if you can group them to use the Pythagorean identities. And then if an expression involves a negative argument, so if on the inside of our trig function we have a negative, consider using even and odd identities. We're also going to need to apply basic algebraic techniques like factoring, multiplying, combining like terms, writing fractions with a common denominator. This will pop up a lot. And then consider writing terms explicitly in terms of sine and cosine. All right, so here are some tips. So if you can't decide what to do next, try to do one of these things on this list. All right. All right, so it just says prove that each of the following is an identity. So one thing to notice is the answer is already here. We know what this thing equals. So the entire proof, all of your work is your answer. So you have to show all of your steps, and your steps are what is the answer. You already know this is going to equal 1. You just have to show that it's true by rewriting the complicated side. All right, so let's get started. The first one, sine of negative x times cotangent of negative x over cosine of x equals 1. So let's work with this. I like to start with the left side, which is usually the most complicated side. See if we can simplify this and make this equal to 1. Well, the first thing that stands out to me is we have negatives, all right, inside of our function. So we're going to use our even and odd identities. Well, both sine and cotangent are negative. So that, our odd functions. Both sine and cotangent are odd functions. So that means we can take our negative completely outside of both of these functions. So I'll remind us. Sine, whenever we have a negative inside, we can take it outside. Cotangent, same thing. All right, let's go ahead and get started. So I'm going to take these negatives out. So this would be a negative sine of x times a negative cotangent of x. And so that's supposed to equal 1. So the things I just used here are the even and odd identities. All right. Next, I notice I have sine and cosine here. This cotangent is throwing things off. So maybe I should rewrite this as a quotient identity, cosine over sine. We've got negative sine of x times negative cosine of x over sine of x all over cosine of x equals 1. All right, so I just used a quotient identity. Okay, notice I have a double denominator. That means these things are side by side. So we got negative sine of x. We also got a negative cosine of x at the top, and in the denominator, we got cosine of x times sine of x. Well, what do you know? All right, I just simplified the fraction. Well, what do we have here? We got cosine over cosine, sine over sine, negative times negative. We should get 1 equals 1. Done. We just verified this identity. So all of this work is the answer, all right? The proving that it's true. Okay, let's try another one. All right, so this one is 1 over 1 minus cosine x minus 1 over 1 plus cosine x, and that should equal 2 cotangent x cosecant x. All right, so I'm just going to work with the left-hand side, okay? And then, let's see. I see two fractions being subtracted. I want to get a common denominator. So my common denominator is just going to be multiplying these two. So 1 minus cosine x times 1 plus cosine x. So that means in the numerator, I have to multiply this one by 1 plus cosine x. Then we want to subtract. All right, I'm going to make sure I put this in parentheses because I want to subtract this whole thing. All right, so I have to multiply this one by 1 minus cosine x. All right, so my first step, I just got a common denominator. All right, what's next? Maybe I should distribute this negative right here. All right, so here, just distribution is what's happened. All right. Oh, well, nice things are going to happen in the numerator, right? So I'm going to combine like terms. 1 minus 1 is 0. Cosine plus cosine is 2 cosine. Well, that's helpful. I got my 2 in there. So 2 cosine x. All right, so this was just combining like terms. Okay. All right, so this still doesn't quite look right. We did get the 2, so that's nice. This denominator is pretty complicated. Let's go ahead and FOIL that out. So we're just going to FOIL this out. All right, so I just FOILed out my denominator. All right, now I can combine some like terms because cosine x minus cosine x is just 0. So I just combine like terms. All right, so let's think about what's next. How can I make this thing look like what's on the other side? Well, I see something that stands out right here. This is a square. That tells me maybe I can use a Pythagorean identity. All right, so off to the side, let's see which one I can use. We got cosine here. All right, so that means I can use sine squared x plus cosine squared x equals 1. Well, what happens, so notice I have a 1 minus this. What happens if I subtract cosine squared on both sides? Alright, so subtracting cosine squared on one side just gives me sine squared x. That sounds better than having subtraction on the bottom. So on the bottom, instead of using 1 minus cosine squared x, I'm going to use sine squared x. And so you should be able to see where this is going now. So we just did a Pythagorean identity. All right, and then last thing, I just need to split up this fraction. So we got cosine x on the top, and we got a sine x on the bottom, and another sine x on the bottom. All right, so these are just rewriting in terms of sine and cosine. Or actually, no, this is breaking up a fraction. Sorry. Break up fraction. All right, finally, cosine over sine, that's cotangent. 1 over sine, that's cosecant. And that's exactly what we were looking for. So once you get to the end, it's very satisfying. So this is quotient and reciprocal identities. All right, so go back over this one if it kind of went over your head.